let's see some special binary trees. They will help us to think about how should the nodes to be organized so that we have the desired property of the data structure. First of all, it's a full binary tree. Okay, what's that mean? A full binary tree have a given height h has 2 to the power h plus 1 minus 1 nodes. Okay, for example, for this one, okay, the height is 3. Okay, as mentioned, okay, is this 0, not counting, okay, 1, 2, and 3. Therefore, it has level of 3. And the total number of nodes is 2 okay, to the power 3 plus 1, okay, minus 1, okay, and know that, okay, it is 15. So it is a full binary tree, and you can see that if you put the number from 0 through the root as 0, and it is 0, 1, 2, 3, so on and so forth. Okay, so it is filled up with the number. Remember, we would put it in a proper order from top and then go down layers and from left to right and do the numbering. Okay, so it would be the case. And another idea is called complete binary tree. Complete binary tree means that all levels are completely filled except possibly the last level. And the last level has all keys as left, okay, left as possible. Okay, just look at this example. Okay, the numbering is the same as that of the full binary tree. Okay, just like this one has 10 nodes. All of them will be numbered from 0, 1, 2, 3, 4, and so forth, okay, until 9. And it will fill up the upper levels. Okay, all the upper levels look fill up, and the last level, okay, the last level will have the nodes putting to as left as possible. Okay, so it is the characteristic of a complete binary tree. And the size of n, that is number of nodes. Okay, the relationship between the height is satisfied 2 to the power h must be smaller than or equal to n, and n must be smaller than or equal to 2 to the power h plus 1 minus 1. So it is the property, okay, you can imagine the relationship. Okay, for example, you can see that this layer, sum of it is 7. Okay, and sum of the total number of nodes, if all filled up, will be 15. Okay, just like previous, the full binary tree. Then there's another property of binary tree, is that which is called proper binary tree. What's that mean? It means that every internal node has exactly 2 children. That it may not be full, it may not be complete, but it is called proper binary tree. So with the definition of a binary tree, actually for all the trees, okay, that is number of total nodes being n. E is the number of external nodes, I is number of internal nodes, H is the height, that is maximum depth of a node. It carries the following properties. First, E must equal to I plus 1. Okay, these, yeah, you can see that, okay, all the squares here are external nodes, all the circles are internal nodes. So E must be equal to I plus 1. And just, you can imagine, just simple calculation, okay, the total number of nodes, that is n, is equal to I plus E, therefore n will be equal to 2e minus 1. And also, you can see that the height must be less than or equal to I. Okay, because that, okay, you can see that that is the highest arrangement with the internal nodes, okay, going layer to layer. Okay, so the height must be less than or equal to I. And by calculation, okay, so you can just do the substitution. Okay, the H must be less than or equal to n minus 1 over 2. And also, by the calculation, okay, you can see that E, that is number of external nodes, must be less than or equal to 2 to the power h. And in other words, okay, when you calculate back, h must be greater than or equal to log base 2 e. Okay, this is just by calculation. Okay, with these, okay, we can do further calculation. Okay, is that, okay, the relationship between the height and the n, okay, which is n must be greater than or equal to log base 2 n plus 1 and the total minus 1. So these are some special properties of these special binary trees: full binary tree, complete binary tree, and proper binary trees.